Hello, my name is Dr. Diwan S. Raja. Today I will discuss about the anatomy of the meninges of the brain. Meninges are connective tissue covering for the brain. They protect the brain. We have also meninges around the spinal cord. Today I will discuss about the meninges around the brain. So the meninges of the brain, we have three layers. One is the Dura matter. Then we have the Arachnoid matter. We have another layer that is the Pia matter. Okay, we have Dura matter, Arachnoid matter, and Pia matter. So the Dura matter, this is the toughest of all the meninges. Okay, is the toughest of all the meninges. And this is the outermost covering for the brain. Okay, and is the outermost covering of the brain. Okay, we got the Dura matter, the toughest of all the meninges, and is the outermost covering of the brain. Okay, so if this is our brain, okay, this is our brain and this is our spinal cord, then the outermost layer is the Dura matter. Outermost layer is the Dura matter. Okay, then with the Dura matter. Okay, then inside it we have the Arachnoid matter. Just inside the Dura matter we have the Arachnoid matter. Inside the Dura matter. Okay, so we have the Arachnoid matter that is inside the Dura matter. This is the Arachnoid matter. Okay, another layer is on the wall of the brain substance here, external surface of the brain over the cortex, that is the Pia matter. Okay, we got the Dura matter, Arachnoid matter, and Pia matter. Okay, so if you look at one of the figure, we have the scalp, then we have the skull bone, then we have the Dura matter, then Arachnoid matter, then the Pia matter. This is the cortex of the brain. This is the middle of the brain. This is the gray matter of the brain. This is the white matter of the brain. Okay, so we got three coverings for the brain. Outermost Dura matter, then just it is underneath this we have the Arachnoid matter, then we have the Pia matter that is on the outer wall of the brain. Okay, we got the Dura matter, Arachnoid matter, and Pia matter. Okay. The Dura matter has two layers. One is the periosteal layer, another one is the meningeal layer. So the dura matter has two layers. One is the periosteal layer. There is the periosteal layer that is just on the inner surface of the skull bone. There is the periosteal layer, and we have the meningeal layer. This meningeal layer is continuous with that of the dura mater of the spinal cord. Okay, we have two layers, periosteal layer and the meningeal layer. So if we go to that figure, so this is the layer. Suppose this is the layer that is the periosteal layer. Then we have the meningeal layer inside it. Meningeal layer, there is some splitting in some places. We get the dural venous sinuses like this. We get dural venous sinuses. So if you think this entire part is the dura mater, then this is the periosteal layer, this is the meningeal layer. Okay, and they are fused together except in places where they will form the dural venous sinuses. Okay, where they form the dural folds and dural venous sinuses, they are splitted. Also in the dural fold area, beginning of the dural fold. So the dural folds are formed by the meningeal layer. Okay, so we have to know that part. Two layers. One is meningeal layer, another one is the periosteal layer. Okay, the meningeal layer and the periosteal layer are separated or splitted. Okay, you can say separated to form the dural venous sinuses, and the dural folds. Okay, and the dural folds are formed by the meningeal layer of the dura mater. Okay, so don't remember that dural folds are formed by the meningeal layer of the dura mater. Okay, we got that. So we have in our meninges, in relationship to that of the dura mater, two potential spaces. One is the epidural space, another one is the subdural space. Okay, these are potential spaces. We have potential space. One is epidural space, another one is subdural space. Okay. Two potential spaces. In relationship to the dura mater, is the extradural space, extradural space, also called epidural space. Okay. Another one is the subdural space. Okay. Subdural space and extradural space. These two spaces are potential space. They are in relationship to that of the Dura method. What is extradural or epidural space? That is outside the, this is the skull bone, this is the skull bone, this is the periosteal layer. We may have a space here, collection of blood here. That is the extradural space. Okay. And between the Dura matter and the Arachnoid matter, we have a potential space here. That is the subdural space. Okay. So extradural space is the space between the skull bone and the Dura matter. That is the periosteal layer of the Dura matter. And the subdural space is the potential space between the Dura matter and the Arachnoid matter. Okay. We got two spaces. Both the spaces are clinically important. Extradural space is the site where we may have bleeding from the middle from the meningeal artery, especially the middle meningeal artery. Okay, we may have epidural hemorrhage there. Subdural space, there is some vein that goes to the dural venous sinuses that may be broken. We may have subdural hemorrhage. Okay, so two spaces are relationship to that of the Dura method. Now we'll go to the folds of the Dura method. They forms partition to keep the brain in well protected condition to maintain pressure and protection. We have dural folds. Okay. So dural fold, we have the Falx cerebri. We have Tentorium cerebelli, Tentorium cerebelli. We have Diaphragma Sellae. Okay, we have Falx cerebelli. Okay, so these are the dural folds. Falx cerebri, Tentorium cerebelli, Diaphragma Sellae, Falx cerebelli. We'll discuss them all. Okay, very good. Number one, Falx cerebri. What is the Falx cerebri? Falx cerebri is a crescent-shaped fold of Dura matter. Crescent-shaped fold of Dura matter. It is like crescent-shaped fold of Dura matter. Okay. This is crescent-shaped. We can call it also sickle-shaped, whatever you may like. Sickle-shaped fold of meningeal layer of the Dura matter. Meningeal layer of the Dura matter. Okay. So we got the Falx cerebri. Anteriorly, it is connected to the frontal crest. Posteriorly, it is mingled or it is adherent and mingled with that of the Tentorium cerebelli. Okay, so anteriorly it is connected to the anterior connection of the Falx cerebri. Okay, the Falx cerebri connections. Okay, anteriorly to the frontal crest and the crista galli. Crista galli of the ethmoid bone. Okay. Anterior connection. What is the posterior connection? Posteriorly, it is adherent and mingled to the upper surface of the Tentorium cerebelli. Tentorium cerebelli. Okay, so this is our Falx cerebri, anteriorly connected to the frontal crest and the crista galli. Posteriorly, it is connected to the upper surface of the Tentorium cerebelli. Okay, we got that connections of the Falx cerebri. This is the crescent shape connection of the Falx cerebri. We got that. What is related to the upper surface of the Falx cerebri? What structure is related to the lower surface of the Falx cerebri? What structure is related to the posterior adherent part of the Tentorium cerebelli? This attachment, this is in the midline of the vault, inner side of the skull. This is attached, and it is attached around the superior sagittal sinus. This is the dural venous sinus. This is the superior sagittal sinus. Okay, so this is the venous sinus in the midline. Okay, on the inner surface of the skull. Okay, along the sagittal plane, we have the superior sagittal sinus. This is the venous sinus. On the free under surface here, this is the inferior sagittal sinus here. Inferior sagittal sinus. And this Falx cerebri is going down between two cerebral hemispheres. If these two are cerebral hemisphere, Falx cerebri goes in between them longitudinally. Okay, so this is separating two cerebral hemisphere, the Falx cerebri. And here we have another dural venous sinus. There is the straight sinus. Straight sinus. This is the straight sinus. That is also a dural venous sinus. Okay, we got the Falx cerebri. So let us summarize again. It projects downwards between two cerebral hemispheres, attached anteriorly to the frontal crest and crista galli of the ethmoid bone, and posteriorly to the it is attached and blended to the upper surface of the Tentorium cerebelli. Content on the upper border, superior sagittal sinus, inferior free border, inferior sagittal sinus, attached border to the tentorium cerebelli. Here we have the straight sinus. Okay, we got the Falx cerebri. Okay, now we'll go to the Tentorium cerebelli. Tentorium cerebelli. Okay, we'll go to the Tentorium. This is also an important dural fold formed by the meningeal layer of the Dura matter. Okay, it is horizontally present here. This part, that part. It separates the posterior part of the cerebral hemisphere from the cerebellum. Okay, it separates the posterior part of the cerebral hemisphere from the cerebellum. You can say cerebellar hemispheres. Okay, cerebellar hemispheres. Okay, we have two hemispheres forms the cerebrum and two hemisphere forms the cerebellum. So it separates the posterior part of the cerebrum from the cerebellum. That is the idea, and this is horizontal dural fold. Horizontal dural fold. This is again formed by the meningeal layer of the Dura matter. Okay, we got that. Now it separates the posterior part of the cerebrum, mostly the occipital lobe. Okay, from the cerebellum. It separates the occipital lobe of the cerebrum from the cerebellum. That is the Tentorium cerebelli. What is the attachment of the Tentorium cerebelli? Attachment posteriorly to the occipital bone, laterally to the upper border of the petrous part of the temporal bone, to the superior border of the petrous part of the temporal bone, petrous part of the temporal bone. Okay, we got that. Anteriorly, it has free border. Okay, but it is attached to the anterior and posterior clinoid process of the sphenoid bone. Okay, anteriorly to the anterior and posterior clinoid process of the sphenoid bone. Okay, we got that sphenoid bone. Okay, we got that. Its anterior surface is concave like this. Concave here. This is concave. Anterior part is concave, forms the tentorial notch. Okay. What is tentorial notch? tentorial notch, the anterior concave border and anterior free concave border, this free concave border of the Tentorium cerebelli. Tentorium cerebelli. Okay. What structure is related to the tentorial notch? The tentorial notch is related to the midbrain. Related to the midbrain. Midbrain. Okay. What is the clinical importance? If there is increased intracranial pressure, then the brain is pushed down through this area. It is sharp and concave, very sharp. So a part of the temporal lobe of the brain may be damaged or lacerated due to increased intracranial pressure, due to tumor, due to hemorrhage. Okay, we got the tentorial notch and tentorium cerebelli. Okay, then we'll go to the diaphragma Sellae. What is diaphragma Sellae? Diaphragma Sellae. This is a horizontal fold of Dura metal connected to the clinoid processes of the sphenoid bone. It covers the Sellae turcica. It covers the pituitary gland. Okay, this is a horizontal fold of the meningeal Dura metal. Over the Sellae turcica. Okay, and covers the pituitary gland. Okay, and this is important. It has a central opening. This diaphragm has a central opening for the passage of the infundibulum and blood vessels. You can call it pituitary stalk. Okay, this has a central opening for the pituitary stalk. Also call it is infundibulum and blood vessels. Okay, so there's opening there, but it covers the pituitary gland in the Sellae turcica, over the pituitary fossa in the part of the Sellae turcica. Is the diaphragma Sellae. What is the clinical importance of diaphragma Sellae? If we have pituitary tumor, then if it is small tumor, it may come out through that opening, or it may bulge out or balloon out the diaphragma Sellae, and it may compress the optic chiasm that may lead to bitemporal hemianopsia. So it is important. Diaphragma Sellae may be bulged, by the pituitary tumor, like the pituitary adenoma that causes acromegaly, okay, tumor, and may compress the optic chiasm. If it is the optic chiasm is compressed, may lead to bitemporal hemianopsia. Okay, so that is possible. Okay, we got the Falx cerebri, we got the Tentorium cerebelli, we got the Diaphragma Sellae. Now we go to the Falx cerebelli. Okay, so Falx cerebri is the longitudinal fold between the two cerebral hemispheres. We have also two cerebellar hemisphere. We have another small longitudinal fold that is called Falx cerebelli. Falx cerebelli. Okay, this is a cerebellar fold. This is another cerebellar fold. We have the Falx cerebelli here in between them. Okay, here is they have shown part of the Falx cerebelli here. Actually, here it is not this Falx cerebri. Here they have shown the Falx cerebelli. This is the location of the Falx cerebelli is here. Here is the Falx cerebelli. Is the Falx cerebelli. Okay, we got that. Falx cerebelli is a fold of Dura matter, meningeal layer between two cerebellar hemisphere. Attachment to the posterior inferior part of the posterior inferior part of the Tentorium cerebelli. Okay, and to the occipital bone. Okay, we got the Falx cerebelli. Okay, now we have gone through the Dura method, and now we'll discuss about the blood supply of the Dura method. Blood supply of the Dura method, or we can say blood supply of the Meninges. Okay, blood supply of the Dura method. Dura method. It is a meninge, so it should be supplied by the meningeal artery. Like we have the anterior meningeal artery, we have the middle meningeal artery, we have the posterior meningeal artery, posterior meningeal artery. Okay, the anterior meningeal arteries are branches of the ethmoidal arteries. Okay, we have the middle meningeal artery. This is the largest of all. This is a branch of the maxillary artery. Okay, these are branches of the ethmoidal artery. Ethmoidal artery. Middle meningeal artery. This is a branch of the maxillary artery. Okay, and how it enters the cranial cavity. The middle meningeal artery enters the cranial cavity through the foramen spinosum. This enters the cranial cavity through the foramen spinosum. It is the largest of all the meningeal arteries. Okay, how about posterior meningeal artery? We can call it arteries, multiple. These are branches of the ascending pharyngeal artery, or these are the branches of the occipital artery. They enter the cranial cavity through the jugular foramen, may enter through the hypoglossal canal or through the foramen magnum. Okay, So posterior meningeal artery may be a branch of the occipital artery or ascending pharyngeal artery, ascending pharyngeal artery, or from occipital artery. Okay, these are branches of the external carotid artery. Okay, we got that. Now we'll go to the nerve supply of the dura mater. Okay, nerve supply of the dura mater. What is the nerve supply? Nerve supply are from the trigeminal nerve. Mostly they are getting nerve supply from the trigeminal nerve. Okay, these are from the trigeminal nerve. Like the ophthalmic division of trigeminal nerve, the maxillary division of trigeminal nerve, the mandibular division of trigeminal nerve. Okay, and posteriorly it get the innervation from the first, second and third cervical nerves. Okay, first, second and third cervical nerve. Okay, so we'll get trigeminal, we'll get the ophthalmic anterior part, ophthalmic nerve. Then we'll get maxillary nerve, okay, mandibular nerve, mostly the middle cranial fossa area. Okay, the mandibular nerve. Okay, so in the posterior part we'll get the innervation from the first, second and third cervical nerve. They enter through the mastoid foramen or may enter through the hypoglossal foramen. Okay, so there are many ways for them to get inside the cranial cavity. Okay, we got that. The nerve supply, blood supply of the dura mater. Okay, now we'll go to the embryology and histology of the dura mater. Okay, first of all, dura mater is what type of tissue? This is an example of connective tissue, which is the toughest layer. The outer layer, dura mater, is the toughest layer. Other two layers, the arachnoid mater and pia mater, are thin. Okay, so this is the brain substance here. Brain, outer layer is the dura mater. Then the arachnoid mater. Then the pia mater. Okay, if you go there. Okay, again try here. Outer layer, dura mater. Then arachnoid mater. Then pia mater. Our brain has a lot of sulci gyri. Okay, so the pia mater goes to the depth of the sulci. Okay, it also adherent to the gyrus. The pia mater goes to the depth of the sulcus of the brain, the deepest area. The arachnoid mater is not. Arachnoid mater is, it does not go inside the sulci of the brain. Okay, and the subarachnoid space is the space between the, suppose we can make it here like that. This is the arachnoid mater. Okay, this is the subarachnoid space between the arachnoid mater and the pia mater. We have a lot of arachnoid villi. So arachnoid mater is thin, transparent. Okay, and it has trabeculae, a lot of trabeculae. So it's just like a spider web, trabeculae attaching to the pia mater. Okay, to the pia mater. We have a lot of trabeculae, and it contains this subarachnoid space contains CSF. This is the subarachnoid space that contains CSF, that is the cerebrospinal fluid. So this is not a potential space, this is a space between the arachnoid matter. This is the arachnoid matter, and this is the pia matter. This is the pia matter. Okay, we got the subarachnoid space and pia matter. Pia matter are on the wall of the cortex. They are enmeshed with blood vessel and they enter into the deepest area of the brain. We call it the sulcus. It is on the sulcus, on the gyrus, and these are the arachnoid. These are the trabeculae. We have numerous trabeculae. Okay, we got that, and we have to know that we have the dura mater. We just know that dura mater has the superior sagittal sinus, and we have some arachnoid villi goes there. Arachnoid villi. Okay, these are arachnoid villi. Villi enters the superior sagittal sinus. Superior sagittal sinus, and the role of arachnoid villi is to drain the CSF from the subarachnoid space to the dural venous sinus, arachnoid villi. Collection of arachnoid villi is called arachnoid granulation. Okay, so arachnoid villi, these are essential for reabsorption of CSF. Collection of arachnoid villi is called arachnoid excuse me, arachnoid granulation. So we are here now. The arachnoid villi, collection of arachnoid villi is called arachnoid granulation. Okay, we got that. So we covered, let me try again. We covered the dura mater, two layers of dura mater. One is the periosteal layer, another is the meningeal layer. This is the arachnoid villi. We have covered the Tentorium cerebelli. We have the Falx cerebelli here. And we should have a Diaphragma Sellae. Okay, and we have gone through the arachnoid villi, and we know histologically the dura mater, arachnoid mater, pia mater, all of them are connective tissue. Now we'll go to the development of the meninges, from where they are developed. Development of the meninges. Okay, they are coming from the mesenchyme. Mesenchyme is the embryonic connective tissue. So dura mater, it is mesodermal. Okay, arachnoid mater and pia mater, okay, they are coming from the mesenchyme plus neural crest cells. Neural crest cells. So neural crest cell contribute in the development of the arachnoid method and PIA method. This is totally from the mesoderm, the Dura method. Okay. We have two more terminology for Dura method. We call it Peckel meninges. Arachnoid method and PIA method together we call them as leptomeninges. Okay, so we covered the meninges of the brain. If you like my video, please subscribe my channel, support my channel. Please hit the button for likings. If you have any question, please feel free to ask me, and also please share the information with your friends. Have a nice day. Bye now.